This question says, distinguish real from apparent cubic expansivity. The next question, which is a calculation question, says a real cubic expansivity for mercury is 1.82 times 10 raised to power minus 4 per Kelvin, and linear expansivity of glass is 8.00 times 10 raised to power minus 6 per Kelvin. If the temperature of 100 degrees Celsius of mercury in glass vessel is raised from 30 degrees Celsius to 100 degrees Celsius, calculate the apparent expansion of mercury. Let's begin with the definition of this. Now, for real cubic expansivity or absolute expansivity, is known as real cubic expansivity or absolute cubic expansivity. We denote it with this. Now, the real cubic expansivity of a liquid is the actual increase in volume of unit volume per degree rise in temperature, while the apparent cubic expansivity of a liquid is the apparent increase in volume of unit volume per degree rise in temperature. The next one, which happens to be a calculation, is we have to calculate the apparent expansion of mercury. Before we do that, we need to know that the apparent cubic expansivity is given by real cubic expansivity minus the cubic expansivity of glass, which means what they give to us is that the apparent cubic expansivity is 1.82 times 10 raised to power minus 4 per Kelvin. Having noted that, we need to know that the apparent, that's the cubic expansivity of glass, is 3 times the linear expansivity of glass, so which is 3 times 8.0 times 10 raised to power minus 6 per Kelvin. So if we calculate that, we will get 2.4 times 10 raised to power minus 5. Now, all we need to per Kelvin, all we need to know now is that if we now use this, apparent cubic expansivity is now equal to the real cubic expansivity, which is 1.82 times 10 raised to power minus 4 per Kelvin minus this, which is what we have gotten to be this 2.4 times 10 raised to power minus 5, and if the difference there will be 1.58 times 10 raised to power minus 4 per Kelvin. So since we've gotten this to be the apparent, but before we get this, remember that the apparent expansion of mercury, which is actually what we are now going to calculate, is given by the volume of that mercury multiplied by the apparent cubic expansivity times the change in temperature. So they told us that the mercury happens to be 100 centimeter. So 100 times the apparent cubic expansivity, which is 1.58 times 10 raised to power minus 4. Now times the change in temperature, it grew from 100 to 30. So final temperature, initial temperature. Now if we calculate all of that, we'll get 1.106 centimeter.